Buongiorno a tutti e passiamo subito alla parte più direttamente. Ringrazio il professor Paolucci per l'introduzione e soprattutto ringrazio Asio per aver offerto la possibilità anche alla voce, chiamiamola epidemiologica, di intervenire in un dibattito, in una riflessione che è di grandissimo interesse anche per questo mondo. Abbiamo con noi la professoressa Julia Heck. Voi troverete nel programma due nomi, Catherine Metayer e Julia Heck. La seconda relatrice purtroppo non è qua per un problema, diciamo così, molto serio per quanto riguarda l'epidemiologia delle patologie pediatriche e della leucemia infantile in particolare. Cioè la professoressa Metayer ha dovuto annullare il viaggio per il decesso improvviso la scorsa settimana della professoressa Patricia Baffler, che è un nome noto nel mondo dell'epidemiologia delle leucemie infantile, dirige il gruppo di coordinamento internazionale specifico sulle cause ambientali della leucemia infantile all'Università di Berkeley, all'Università della California Berkeley, e la professoressa Metayer è la sua allieva, il suo braccio destro. Questo fatto nel mondo dell'epidemiologia di questa patologia ha prodotto così profondo cordoglio per questo decesso improvviso e ha provocato questo annullamento. Ci rattrista ovviamente la causa, ci dispiace il motivo e la professoressa Metayer però mi ha detto di comunicare che se ASOP è interessata, se l'udienza è interessata, il prossimo anno conterebbe di riparare a questa sua assenza fermandosi a Modena per un contributo su queste problematiche. Julia Heck, professoressa Heck, viene dall'Università della California di Los Angeles e ci viene a parlare delle cause ambientali dei tumori infantili. Un argomento che è stato poco frequentato fino a qualche anno fa nel mondo dell'epidemiologia, mondo a cui appartengo, quindi della sanità pubblica, che generalmente aveva altre priorità di ricerca. Negli ultimi anni soprattutto i grandi centri internazionali, più modestamente qua a Modena, ma certamente i grandi centri internazionali stanno investendo molte risorse, che vuol dire molte persone, molti soldi e soprattutto una grande attenzione a un argomento che tradizionalmente era meno rilevante per noi ed era tutto in ambito oncologico e pediatrico prima di tutto, cioè quali sono i fattori, se esistono, di tipo ambientale che possono avere una rilevanza nell'insorgenza delle patologie oncologiche pediatriche. E quindi mondo epidemiologico e mondo delle scienze ambientali. Noi ringraziamo di cuore la professoressa Heck per essere venuta dalla California, per essere venuta apposta dalla California per questo contributo. La professoressa Heck ha svolto e pubblicato proprio pochissimi giorni fa, è entrato nella banca dati biomedica PubMed circa un mese fa, quindi non è ancora disponibile nella sua forma definitiva, il più grosso studio mai effettuato fino ad oggi sulle cause ambientali e soprattutto sui fattori dell'inquinamento atmosferico che possono essere correlati all'insorgenza delle malattie neoplastiche in ambito pediatrico. Ha fatto uno studio di dimensioni straordinarie, ha arruolato più di 10.000 casi di tumore infantile nell'intera California. Questo studio ha avuto larga eco nei mezzi di comunicazione statunitensi e oggi credo, anche se non ho visto la sua presentazione, però che ci presenterà in anteprima i risultati di questo studio, immettendoli all'interno di una cornice più generale dei fattori di rischio ambientali dei tumori infantili. Il curriculum della professoressa Heck è lungo 9 pagine, ovviamente lo riassumo in 3 parole. Laurea alla Columbia University New York nella School of Public Health della Columbia University, un periodo prolungato di attività scientifica allo IARC di Lione, che voi sapete è l'Agenzia Internazionale per la Ricerca sul Cancro, l'organismo dell'Organizzazione Mondiale della Sanità deputato al studio in ambito epidemiologico e normativo delle cause ambientali dei tumori, e infine la sua attività didattica e di ricerca presso l'Università della California a Los Angeles, la UCLA. Grazie alla professoressa Heck per essere qua con noi e la parola a Julia Heck.
Thank you for having me here today. I'm delighted to be here. And so my talk today is on the environmental causes of childhood cancer. And I wanted to start by showing the incidence of childhood cancer across different countries. Is this one better?
Chiedo scusa, dovrebbe esserci la traduzione simultanea disponibile se inserite le cuffie direttamente lateralmente alla vostra poltrona.
This was a study done in Padua, actually. They asked parents of children with leukemia what caused their child's cancer, and about a quarter of the parents said that they believed that it was because of radiation. That's right there. And then another quarter said that there was some other environmental cause, and in yellow, another quarter said the cause was genetic. And then the rest said unknown. And in fact, it's much less understood than this. I apologize, this is quite small, but this shows the proportions of cancers that can be attributed to a known cause. And in adults, there's quite large proportions of many cancers we understand the causes of. The first cancer listed is oral cavity and pharynx, and 85% of tumors can be attributed to a known cause. And then when you go down the list, the first childhood cancer there is leukemia, in which only 2% of cases can be attributed to a known cause. So it's just the comparison between childhood and adult cancers in terms of the understanding of the etiology is very stark. These are the only established causes of childhood cancers. Inherited genes account for less than 5% of all tumors. Parental smoking is considered an established cause of hepatoblastoma. Also, ionizing radiation, chemotherapy, DES, and rare genetic syndromes. And consequently, over 90% of childhood cancer cases have no known etiology.
Sorry Giulia, number one, scusate, il numero 1, dovete schiacciare il pulsante numero 1 perché per alcune persone non era settato correttamente nel cursore anteriore per avere la traduzione in italiano, grazie.
So I'm only going to speak about the two causes today which might be considered environmental. Parental smoking, and studies have looked at that either preconceptionally or smoking during pregnancy. And it is considered to be an established cause of hepatoblastoma, but the classification, which was done by IARC, was based upon only 4 studies. And this classification came out a few years ago, I believe in 2010, and all the studies that have come out since that time have not found any association. So I'm not completely convinced that this is a true association. However, there is growing evidence that the father's smoking before conception may be associated with acute lymphoblastic leukemia. There was a meta-analysis that showed an increased risk by 12% increase by paternal smoking. And there's also a pooled analysis that will be coming out soon that found the same result. That's in the CLIC consortium. Ionizing radiation is defined as radiation with sufficient energy level to knock an electron out of an atom. And there are several different types of radiation, but the most relevant type for childhood cancer exposures would be X-rays that occur during pregnancy or early childhood. And there have, of course, also been studies of atomic bomb survivors. This was the first study that linked abdominal X-rays in pregnancy to leukemia in children, to leukemia mortality. And it's very well done, I think, the way they did it. They asked mothers when they had had X-rays, and they looked at the time period, so either before the marriage, between the marriage and the relevant conception, during the pregnancy of the child who got leukemia, or at any time, and where the X-ray was, whether it was on the mother's abdomen or another location on her body, and that's any place. And so the highest relative risk can be seen for abdominal X-rays that occurred during the relevant pregnancy. This was a fairly convincing study, and the others that have come out since have found similar results. And ionizing radiation is linked both to leukemia and to solid tumors of all sites in childhood. So that is it for the established causes of child cancer. There's so few things that are known, but there are other causes that are suspected. Electromagnetic fields, which include wireless telephones and residential proximity to power lines, would be of these exposures. There was a meta-analysis done in 2001, which found a 65% increase in leukemia risk among children exposed to magnetic fields. However, there are some concerns about the quality of the studies that were done, in part because the measurements were indirect. They didn't actually measure the magnetic field, say, in the child's bedroom, but they made a guess based upon the distance between the bedroom and the nearest power lines, for example. There's also some studies that had low response rates. But there has not been consistent evidence for any association between electromagnetic fields and childhood brain tumors or other cancers in childhood. So there's also been a number of studies of electrical appliance use in the home, but no clear pattern has been discerned. So there's very little known about other cancer types other than leukemia. There have also been a number of studies that looked at residential proximity to nuclear plants or other nuclear facilities, and there have been reports of higher incidence of cancer near several ones in the United Kingdom. However, there's an alternate hypothesis about what the cause of this may be. It's believed that nuclear plants tend to be built in very rural areas where the population was very small and they had been living there, the same families had been living there for a long time. But when they build the plant, all these new people come in, and many people come in to build the plant and many people come in to work there. And so the hypothesis is that it may be due to some new infectious disease, some kind of infectious cause being brought into the population. And it's not necessarily that they believe that there's a specific virus or other agent that's responsible, but it may be the way that the children's immune systems are responding to these new pressures. For example, it's another hypothesis is that children who are exposed to many viruses very early in life build very strong immune systems, but children who are not, say, in these situations because they're living in a very remote area, and then their immune system gets challenged a few years later, perhaps it's just an abnormal reaction of their immune system. So it isn't clear that any increase in childhood cancers from living near a nuclear facility is necessarily because of radiation. In addition, there's a lot of natural radiation that we are already exposed to. The largest proportion of all radiation that we're exposed to is from natural causes. And then of the man-made causes, a large proportion is from X-rays or other nuclear medicine. And only a small amount of the overall radiation we're exposed to is from the nuclear fuel cycle. And there was a large study done in the United States in 1990 that compared cancer mortality in 300 U.S. counties before and after facilities were put in, and it found no association. In terms of other potential sources of pollution that might cause childhood cancer, traffic pollution and pesticides have both been studied, and I'll talk more about those when I talk about our studies in California. There's also been a number of studies that looked at industrial sources of pollution with regards to residential proximity near petrochemical plants, power stations, oil refineries, and so on. But the number of studies has been quite small, so it's difficult to draw conclusions. And there's also been a few studies linking cured meats in the diet to childhood brain tumors. So I wanted to talk about our UCLA study on air pollution. There have been a number of studies that examine traffic pollution and in particular childhood leukemia. And of the studies that had quite good exposure assessment, they found average 130% to 290% increase in leukemias with high traffic exposure. And that's sometimes during pregnancy and sometimes during childhood. There was also one study that found no association. And there was a study that found an increase in central nervous system tumors. So in California, where we have such a large population, we conducted a population-based study of children who were listed in the California Cancer Registry from when it started in 1988 through 2007. And these were all children less than 6 years. And we linked them to California birth certificates. We were able to link about 90% of the cases in the registry to a California birth certificate. So the rest probably moved in from out of state. And then we geocoded the residential address based upon the address that was listed on the birth certificate. And we measured air pollution in 3 ways. Land use regression, which was for LA County only, Caline form modeling for the whole state, and then also what's called proximity modeling to look at air toxics. So the purpose of land use regression is to predict pollution concentrations at a specific site based upon the surrounding land use and traffic. And it provides estimates of nitrogen monoxide and nitrogen dioxide. The LUR model includes information on traffic volume and truck routes, land use data, brightness and greenness, and it creates a surface which allows us to ascertain the traffic exposure at very specific sites. We also hung 200 monitors across Los Angeles County across 2 seasons in 2006 and 2007. And here's what our air monitors look like. And the model includes information on green space and brightness, which is important in ozone formation, and ozone reacts with nitrogen monoxide to form NO2. And this is what our model ended up looking like. The one on the left is nitrogen monoxide, and the one on the right is NO2. NO is what comes out of the tailpipe of a car, and so that's why the model looks so closely like the highway system in Los Angeles. And then NO2 is formed when NO reacts with other chemicals in the atmosphere, which is why it looks more diffuse. And I should say that carbon monoxide and all traffic-related pollutants have been dropping in Los Angeles across the past 20 years because of changes in gasoline formulations. But nonetheless, it shouldn't change the surface of our model. So what we found was an increase in acute lymphoblastic leukemia, and also we observed higher risks for bilateral retinoblastoma and for ependymomas. And when we looked by trimester, it looked like the second trimester might be more important for ALL and the third for bilateral retinoblastoma. And then we did a separate analysis using Caline-4 modeling. It's slightly different than the LUR model because it's more concerned with how chemicals mix together over the roadway and then disperse over distances. And so it also includes more information about meteorology or weather. And it includes information on both mobile sources of pollutants, which is traffic, and stationary sources such as a power plant, for example, that emits pollutants. And this was a little different than the other model because it was for a shorter time period. And although we looked by trimester, our trimester periods were very highly correlated, so we weren't able to figure out if there was a trimester that would be most important for this exposure. And as it turned out, we saw very similar results with associations with acute lymphoblastic leukemia, retinoblastoma, particularly bilateral. And in this case, we saw an association with germ cell tumors. And when we looked at what histologic type the germ cell tumors were, it was teratomas, whereas there was no association with yolk sac tumors. And finally, we did proximity modeling, and I'll just describe that briefly. The state of California conducts regular air monitoring of both of what are called criteria air pollutants, which is sulfur dioxide and nitrogen dioxide and so on, but also of specific air toxics. And there's not so many stations that collect information on air toxics. As you can see that at this map, there's maybe about 15 or 20 in the state. That area up there is the San Francisco area, so there's several monitors there. And here is Los Angeles, and there's 4 monitors there. And the remainder are in rural areas, and I think they're intended, these monitors are not put around the state randomly. They're put near very high polluting, they're put in high polluting locations. So I think that these other ones are intended to ascertain pesticide spraying, for example, or if maybe there's some large industry there that I'm unaware of. And the last monitor, actually, the one down here at the bottom, can I get this? Is actually not in California. It's across the border in Mexico, in Mexicali. This is what the data end up looking like. As you can see, there's real seasonal differences in the concentrations of pollutants, and that's because in California we have inversion layers in the wintertime, so it keeps the pollutants there and you get much higher levels. And each line on this shows the average level in each month at a specific air monitor site. And the line that's in pink is actually the one across the border in Mexicali. I'm not sure what pollution they have there, but it seems to be quite bad. And just to show you what the proximity models do, essentially in the middle is the air monitor, and then we just choose a buffer distance around it, a radius, and we assign the children who are living there to the value at that monitor. And so then, it ends up, if you can have a small radius, then you can hope that you have good exposure assessment. But if you must go far out, then you become a little more concerned about the accuracy. This is Los Angeles County, and just to give you an idea of what they're trying to look for, the two circles at the top there, Burbank and Los Angeles, that's where some very large highways go by. North Long Beach at the bottom, there's a very large port in Long Beach, and 40% of the goods that enter the United States come in at Long Beach. So this generates thousands of truck trips every day. So I think they were trying to capture diesel pollution at that monitor. And then along the top, there's a mountain range that comes down here, and so the air gets trapped over on the side where Azusa is. So in each of these cases, the monitor is at an area where pollution is expected to be very high. And these are all the air toxics that are collected. Well, there's actually many more than this, but these are the ones that are considered to be suspected or established carcinogens. So when we analyzed the data, our largest concern was that the air toxics tend to be highly correlated because many arise from the same sources. So to deal with this, we conducted a factor analysis, and we're just grouping highly correlated toxics together. The first group, which was benzene, toluene, ethylbenzene, and the xylenes, these are all toxics that arise from traffic. They're collectively called BTECs. And then there were 3 other toxics that grouped with them in the factor analysis, even though they don't arise from traffic. Those were perchloroethylene, lead, and styrene, and they're correlated with the BTECs because they tend to be released in urban areas. Perchloroethylene is it's from dry cleaning, and styrene is emitted from office machines, for example. Then the second factor was all the polycyclic aromatic hydrocarbons, and the remainder of the air toxics were not very correlated with other toxics, so they didn't load into a factor. So then we looked again at retinoblastoma, and we found strong associations with all of the traffic-related pollutants, but the highest association being for benzene. And then when we looked at the other air toxics, we observed associations with chloroform and chromium with retinoblastoma, and also paradichlorobenzene, which is in air fresheners. The air fresheners that people might have in their house, for example, they emit the dichlorobenzenes. And then we also did the same thing for neuroblastoma, and we found some associations with PAHs. But the most interesting thing for neuroblastoma was that we looked at different buffer areas. We looked first at 5 kilometers away from the air monitor, and then we shrunk it to 2.5 kilometers. And at 5 kilometers, there was a quite high association with carbon tetrachloride. It went all the way up to a 7-fold increase at 2.5 kilometers. Carbon tetrachloride is released in California only at a few different sites. So this was a new finding, I think. I'm not sure anyone else has found associations with neuroblastoma and carbon tetrachloride. It would be interesting to see if someone else has a way of studying this, which I don't think is possible. And I just want to show some of the sources of some of these pollutants. It's just different kinds of manufacturing in general. We also have a study on pesticides. Pesticides have not been definitively associated with childhood cancers, and the reason is because they're very difficult to study, at least in the United States. Perhaps it would be easier in Italy. But in the United States, you know, if you want to study an agent, the first thing that you want to do is to study those people, the people who are in contact with that agent at a very high level. But in the US, the people who do this tend to be migrant workers, and so they're leaving the country, they're going back to their home countries, and we have no way to track them. So that's one reason why it's difficult. And the second reason why it's difficult is because farmers use a variety of pesticides, and the pesticides they use may have multiple chemicals in them. So people are being exposed to many, many different chemicals. And from the point of view of a regulatory agency, they would much prefer, if it would be possible, to really pinpoint which chemical it is that's causing the cancer or causing whatever disease. And it's just very difficult in pesticide research to be able to do that when you study humans. With animals, of course, you can just give them one, and that's more suggestive than anything we can do with humans. But there have been many studies on pesticides and childhood cancers, but they generally follow the same format, where parents are asked about their home pesticide use, or, you know, do you spray for bugs in your home, or do you use herbicides in your yard? And these have quite overwhelmingly shown associations with childhood cancers. In particular, that's true for Wilms tumor, ALL, AML, and less so for other sites. But in California, we're taking a different approach, because in 1972, California passed a law which required farmers to report to the state about which pesticides they put on their crops. And California has a very large amount of the farming in the United States. So it's a substantial amount of pesticides that are put down. And this is what the pesticide use reports, they're called PUR, pesticide use reports. This is what they look like. So the farmer would say what county they live in. They have a geolocator, which links the report to a specific, it's like maybe a 8-kilometer square area. And the type of commodity, the crop it's put on, in this case it's grapes, the method of application, which in this case is ground spraying, and the chemical, and the amount that was put down. So we put this into our computer system so that we have all that information, and in addition, we cross-linked it with maps of land use, which show crop patterns. So if we start with this 8-kilometer square area, and when we know that, say, the pesticide was put on grapes, then we can show even within this area where the pesticide was likely put down. And so we've developed this computer program to try to pinpoint precisely where the pesticides are being put down. And then when we have the child's address, then we can choose some buffer distance around the home. In this case, we usually choose 500 to 1,000 meters, and we can make an estimate of how many of each pesticide they were exposed to. And our results are rather preliminary, but in particular we're seeing associations with brain tumors and astrocytomas most strongly. And that is it. Please tell me if you have any questions.
Grazie alla professoressa Heck, e ovviamente uno spazio per qualsiasi tipo di domanda o curiosità e richiesta sulle problematiche direttamente o indirettamente toccate dalla professoressa.
Not very well. A little bit.
Okay, now you can hear me better? Okay. My question is, in California where you have the air monitors, right? Are there any air monitors there along the highway that you can report, or you can, collect or is it only where the residential area that you have the air monitors where they capture the pollutants that are there?
I actually don't think they put them in residential areas because I think they put them close to the polluters. So it's not necessarily, they don't do it for research. They do it for their own, they're trying to ensure that the air quality is good. So I think that they are quite close to highways, in fact.
Because it's mainly the highways that are more populated, or there's more traffic that's constantly going on compared to residential areas. So
yeah,
I was only curious that way, is that when they do the studies, are they considering, because when you have the residential, you consider the meters, and you have a patient there who has a cancer reported, and you have kind of a correlation that, okay, we're seeing so many pollutants here, and it is related to maybe this kind of cancer, but it's not necessary that that patient is there in the same location where the highways are there, where you'll have much more pollutants compared to residential area.
So you're saying that maybe the patient isn't living right by the highway, maybe the patient is further away?
Ideally, I would assume it would be that way, because where you have the highways, it'll be connecting to different areas, whether it's Long Beach or your California, the entire map that you showed. So when you have the highway, there are people who travel up and down, either for work or whatever reason. If you have an air monitor that's there along the highway, you can maybe, for sure along the highway, you will not find residential area.
No, actually, people do live straight up next to the highway in California.
Oh. Because it would be interesting to see whether, is there a variation or is there a difference really? If an air monitor is kept very close to the highway, does it absorb or does it catch on more pollutants compared to the air monitors that in a local residence where you've located a patient that's suffering from a particular kind of neuroblastoma or any other kind, or MAL or ALL?
Well, I would say that you're right that there are real concerns with proximity models, but I only used that for the air toxics. No. But I think that's why I got such high effect estimates, because the air monitor is measuring something that's very high because it's right there where the air is the worst. Whereas the other models that we used were intended to have much more variation and to be able to predict the distance or predict the levels over a long distance. Sure. So, but I think you're right. But in fact, it's not like here where the highways are outside the cities. The highways go right through the cities in California, and people are living right up next to them. So it can be pretty bad.
Okay. Thank you.
I was wondering whether you had looked at your correlations among different ethnic groups, and if there was any relation between the incidence of certain cancer and where certain ethnic groups predominantly live.
We're so interested in that question ourselves, actually, and in particular because the high rates of leukemia among Hispanics in California, and leukemia is higher among Hispanics than among European Americans. So we have actually looked to see whether, say, it's only people of certain ethnic groups who are living around the highway, and it's not really true in Los Angeles and in California as a whole, in part because the rural parts of California have large numbers of white Americans. The wealthiest people in California tend to live in the cities, and air quality was particularly bad along the highways, say in the middle of Los Angeles, but air quality was also bad in other parts of the city, which were not where the ethnic minorities were living. There's actually less of a correlation than you might think, at least in California.
Julia, thank you very much indeed for the presentation. I have always this problem when I try to understand the epidemiological data concerning childhood cancer. And the reason for that difficulties relies on the fact that, as you know, the genomic profile of childhood cancer are completely different as compared to the ones of adult at least the adult cancer, for which clearly you have a biological plausibility that an environmental factor can really play a role. And I was very impressed in the recent review by Bert Fokelstein, where you have this very nice picture comparing the number of mutations which came out from genomic studies in children as compared to adults. So the question I do have, again, because we are dealing with cancer in adults, where clearly you have very high number of mutations, which to some extent clearly give you the sort of plausibility that the environmental factor can play a role. And so how do you explain that? Because you know better than myself that we do have always this concern about the parents asking whether I'm living close by to a EM field or whatever. And actually the answer is that you are not able to provide a clear clue on that because we do not have any biological plausibility of some of these observations.
Well, there have been actually a number of studies that have shown that exposure to certain chemicals can cause eye disorders in adults. For example, there have been studies of people who have very high carbon monoxide exposure, and it can cause bleeding in the retina. And in addition, there have been studies of maternal smoking in pregnancy, and that is shown to cause eye disorders in children, in the fetus. And it is believed that the fetus is more vulnerable than the adult to environmental exposures. So, and there have been actually some other studies where certain air toxics, there was a study where nickel was injected into the eyes of rats, and those rats did develop retinoblastoma. So I cannot, I don't know if I can speak to the mechanistic data, but I can say that these sorts of effects have been seen with other exposures, at least with retinoblastoma.
So thank you very much for the presentation, and I'm just following up what Andrea just said. So the complexity of cancer is very high in pediatrics. And so I'm wondering whether we could look to the impact on those chemicals into other fields, like in the immunological systems. So cancer can raise up also because of immunodeficiency, right? So I'm wondering whether you looked to, markers which are predictive of immunodeficiency population, essentially. So the cancer is going to raise up because of an impact of your chemicals in the children's immune system. So any comments for that?
No, I think that's an interesting idea. We haven't thought to look at that.
Altre domande?
Bene, grazie alla professoressa Heck per il suo contributo e cedo la parola al professor Dominici.